Hey guys, so welcome back for lesson 3 about displaying data. So this is going to be about some different kinds of representations we can make of quantitative data. So let's get cooking. The first one is a box plot. So a box plot is made up of a few different parts. So you might have also seen these called box and whisker plots. So what we have here, these stars are outliers. So if something is an outlier, we're going to denote it using little stars or dots or something outside of the box plot. The lowest whisker, or so the low point of the box plot, the minimum value right here, is going to go from you're going to draw a line from the minimum value to this line right here, which is the first quartile. And then in the middle of the box, you're going to have this line right here, which is the median, whatever it happens to be. And then at the end of the box, you're going to have the third quartile. And then this value out here will be the maximum value that is not an outlier. So we're going to show how this works by creating a box plot with this data set that we've been working with. So what we want to do is, first we want to draw ourselves oh my gosh, that was a terrible line. So we want to try and draw ourselves a better looking line than that. So there's our number line. So let's just say this is 0. And we've got this number line labeled 10, 12, 14, 16, 18. We really don't need to keep going, but I drew this whole line, so I want to use it. All right, so we're going to start with the minimum value. So our minimum value is 1. So down here at 1, we have our minimum value. All right, and that is going to go until the first quartile, which remember our median was right here at 5.5. This was Q1. So 5 is going to be Q1. So right here at the first quartile, we're going to draw one end of the box. So I've got a line going from 1 to the first quartile. The median was 5.5. So we're going to draw the median right here. And then we're going to start drawing our box. Remember, Q3 was 8. So we're going to draw the end of our box here. So now we've got our box. And then our maximum value is 17. But remember, 17 was an outlier. So instead of drawing this all the way out to 17, I'm going to put a star right here for 17. And our maximum value that was not an outlier was 11. So now we can look at our box plot and we can see that 17 is included in our data set, but it's an outlier. So that's an example of a box plot. Your calculator can also make a box plot. And we will go through how to do that in class. So next up is a histogram. So a histogram looks kind of like a bar graph, but it accomplishes something completely different. Bar graphs are used for categorical data, which is when you just sort things into categories. Histograms are used for quantitative data, so numbers. So what a histogram is going to do, so I'm going to start at 0 here. I'm going to have 1, 2, 3, and 4, and that should be good. Okay. So what we're going to do on a histogram is we're going to label our axes. So we've got 2, 4, 6, 8, 10, 12, 14. We're going to extend this a little bit. 16, 18. So what we're going to do with the histogram is this interval from 0 to 2, what I'm going to do is I'm going to look at my data set and I'm going to see how many of my data points fit in between 0 and 2, and I'm going to draw a bar right here. So I have one data point between 0 and 2. So I'm going to draw myself a little box like that to represent that between the values of 0 and 2, I have one data point, and that's this one right here. Next, I want to look at my next portion of the data, so 2 to 4. And what we're going to do is we're going to include 4. So from 2 to 4, I have one data point that's included. So I'm going to draw this box right here. All right, so now I'm going to move on to the next one, 4 to 6. So from 4 to 6, I have 1, 2, 3, 4 data points. So I'm going to draw this terrible looking box. Let's see if I can make it look nicer. Oh, that did not help at all. So I'm going to draw in this bar right here. That is not even close to a straight line, but you understand the point. So we've got that bar to represent that there are 4 values between 4 and 6. We're going to move on to the next one. From 6 to 8, we have 2 values. And then, man, I'm not very good at drawing on this little drawing pad thing that I have. But we're getting the job done. So 6 to 8, we have 2 values. 8 to 10, we have none. And then 10 to 12, we have another one. We have 11 between 10 and 12. So we're going to include this bar. None between 12 and 14, none between 14 and 16, and then finally, one last value between 16 and 18. So this would be an example of a histogram. Basically what a histogram shows is it shows us how many values are in the data set between specific bins, between specific bin values of the histogram. So now let's look at dot plots. So what dot plots do is, let's just number this. We've got 1, 5, 10. So when you're putting a dot plot on some axes, what you want to think about is the minimum and maximum values that you have. So our minimum is 1, our maximum is 17. So we want to make sure that we can include every value between 1 and 17. So what a dot plot does is I go a value at a time. So 1, I have 1 value in my data set that's a 1. So I'm going to put typically a dot. I'm going to use an X so it's easier to see. So I have 1 value that goes with the number 1. I don't have any 2s, no 3s. I have 1 4, 3 5s, and so on and so forth. Basically what I do is for each number, I'm going to put a dot, an X, something that denotes how many of that number I have. So then I have a 6, a 7, an 8, no 9s or 10s, an 11, and a 17. So this would be a dot plot of our data. For smaller data sets like this, it doesn't tell us a ton, but when you start getting larger and larger data sets, dot plots are very, very helpful to see the shape of the data, as are histograms. Histograms are also extremely helpful for seeing the shape of data when we start to have larger data sets. And if you look, this pattern of the histogram kind of looks like the pattern of the dot plot. We can see where the most common values are located and centered. And we can also see kind of the spread of the data. So the last kind of plot we're going to look at is a stem plot. And you may have heard these called a stem and leaf plot also. I picked some different numbers for this one because we need to show this a little bit differently. So what a stem plot is the stem of the stem plot is the first digit of the possible numbers of the data set. So I have numbers with first digit of 1, first digit of 2, 3. I don't have any with the first digit of 4, but I am still going to include that because I need to know that there's nothing in the data set that starts with a 4 and then a 5. So this is the stem. And what we're going to do is we're going to draw the leaves by looking at these data points saying, all right, this is 1. I have 11. That is 1, 1. I have 13, and that is 1, 3. And then I have 17, so that is 1, 7. So what this tells me is there are 3 numbers in this data set that are 11, 13, and 17. I'm going to do the same thing with the 20s. I've got 21, 26, and 28. So one big advantage of stem plots is that over if you compare them to box plots, histograms, and dot plots, box plots and histograms, I can see the actual values of the data. So I can see 21, 26, 28. So now I've got 33, 39, and 39. One important thing to notice here is I actually put 2 9s because there are 2 numbers that are 39. So because there are 2 39s, I need to make sure that I include the value for each one of those 39s. And then finally, I've got 51, 53, 55, 55, and 56. So again, one of the Positives of this is I can see the actual values of the data set. And this would also be another good way to look at the shape of a set of data. So that's it for today's lesson. Today we talked about 4 different ways to display data, and those were box plots, histograms, dot plots, and stem plots. So I hope you guys took some notes. I hope you come to class with some questions. We're going to practice making some of these charts in class. I hope you have a great day.